Hello, is there?
Yeah, Vasan.
Yeah. Oh, okay. Yeah. We'll start with the next slide. So, what are we going to learn? So far we saw who should learn, or who. I mean, like, again, at the end of the day, we we could see like anybody who's interested to keep these systems available, reliable, and operational. Yes, they can learn. So, what are we going to learn? Uh, so the question is, what does it actually mean to be an SRE practitioner? So, do you think that it's just another IT role, or do you think it's a mindset? So, what do you think? I mean, like, you must be interested in by the time like you think that okay, I can become an SRE. So, what do you think? It's just another role, or do you think that it's going to be just a transforming way, or it's going to be transforming the entire approach of reliability? So, any idea, like anything is fine.
I think it's not a specific role because I've seen in some of the organization like DevOps do this kind of and some of the organization only performance testing engineers they do this kind of so it is a role but in limited in some of the companies only as of now.
Exactly. Yeah, that's true. Not every team or every organization has an SRE role, but it's a must for any application to keep the reliability because everybody wants to be up ahead of every competitor and up ahead of the business. Yes, so they have to manage, they have to balance the reliability and the speed. Yes. So what are the core principles of SRE? So before we dive into the practices, we need to understand the philosophies behind SRE because these core principles will shape us how we are going to achieve the reliability in real world systems. So the first thing is embracing the risk with with error budgets. So when I say embracing risk, we all know we think that uh, perfect reliability is a myth because any system or like no system can be 100% failure free. But what SRE does is it embraces the risk by setting the error budgets. So when I say error budgets, we're going to set some budget for the errors, which allows the teams to innovate without sacrificing the stability. Because we saw that, okay, we have to manage the innovation and we have to manage the speed. But by doing this part, that is embracing the risk with error budgets, we are going to have a system which can be 100% failure free. But again, we're going to embrace the risk by setting the error budgets and we're going to allow the teams, that is, the business is going to allow us to innovate without sacrificing the stability. And the second point is we're going to automate over the manual work. So if something is repetitive, we as an SRE, our first instinct should be to automate it. So automation, like for example, a very small examples, I would say, like starting the VMs or starting the machines at the morning should be automatic. It's not someone should come into the system and he should start the machine and only then everybody should be able to use it or only everybody should be able to access it. It's not something like that. So you should automate those systems. This is just an example I'm say bringing, and at the end of the day, shutting down them, right? So automation reduces the toil, it prevents human error and humans effort as well. It reduces the human effort and it ensures the reliability at scale. So that's the reason we need to bring in the philosophy, or we need to bring in the principle of automation over the manual work. And then we have to measure what is SLI and SLO. So SRE is completely data driven. So when I say data driven, the teams define the SLIs, that is service level indicators and service level objectives, to ensure the system is performing as expected for users. So that is the reason we are the SRE. We say that we are data driven, and then we do like blameless postmortem. So when I say, okay, again, postmortem is something that every SRE engineer should know. But again, we should think about the point called blameless postmortems, because it's like we should not blame someone like, okay, you are the reason for this or someone is responsible for this. It's not just like that. Failure is inevitable. It's you cannot stop it. Failure is inevitable again, I would say, because learning from it is very critical, because you will never learn something until you meet the failure. If you are, if the system is completely reliable and if you haven't faced any failures, I would say that you haven't learned anything. Only when you face a lot of failures, it's not just only in life, but it's also about the SRE, the reliability, you will keep on learning new things. So instead of pointing fingers on someone, that's instead of blaming someone, SRE encourages blameless postmortems to improve future reliability, right? So out of all these, um, which one do you think would benefit your current work the most? Like, you are in a team now, and you are you're following certain principles. So how does your team approach the work? Or I would ask, like, what is one principle that you follow in your current team? That is that something like you automate things over your manual work, or uh, do you really think that, okay, there are like blameless researchers happening in your team? Like, do you think any of these, at least one of these principles, is currently implemented in your team, or do you think that, okay, no, nothing is like nothing is like that, but we can implement that while I migrate myself to SRE? So anything, any comments is welcome. Yeah, I think someone is unmuted. You want to add anything?
No.
Okay, great. Fine, no worries. So let's move on to the next topic, which is the key practices that bring these principles to life. So when I say these principles, the SRE principles. So now that we know why the SRE exists, right? So we saw about various principles and various ideas on like what SRE and what they do. So let's now dive into a little bit of what the SRE practitioners actually do in their day-to-day roles, because this is very important. We need to know, right? As when we move into SRE, we need to know, as an SRE, what should I do? What is my day-to-day roles? So the first thing is, um, am I on the right one? Okay, yeah. First thing is monitoring and observability. So SRE relies heavily on logging. That's the logging information, logging, and then the metrics, and then the tracing to monitor the system health and identify the issues before they become major incidents. Yes. So as an SRE, we should always have an eye on logging metrics and the tracing part, so that we are keeping track on the system's health. Because if we keep on systems health, then at some point of time we know, okay, there is something, uh, some failure is going to happen, so we can prevent it, right? But if we don't notice, or if we don't monitor it, or if we don't identify the issues, then it might take us to a major incidents. The second thing is capacity planning and scaling. So as an SRE, we must ensure that the application can handle growth, because we all know every business, their main objective is growth. So if an application is using 1 million users, their goal is to have 10 million users by next 6 months, or by next 2 quarters, or like 3 quarters, right? So when that is getting improved, or when that is getting scaled up, our application also must handle the growth without the performance degradation. That's the important point. Without even any degradation in performance, we should handle the growth by proactively managing the resources, the load balancing, and auto scaling. So all these has to be, as a performance engineers, we know these points, right? The load balancing, yes, we know. The resources, yes, we know. Auto scaling. So that's the reason why performance engineers are mainly, very much suitable, or very much closer to these SRE roles. The next thing is incident management and disaster recovery. So instead of reacting to incidents in chaos, SRE practitioners follow some structured response playbooks, or they have a run book kind of thing, where the SRE engineers will conduct disaster simulation. So that's the reason we do this chaos engineering, where we simulate the disaster scenario, and we find like what is the reason and how to fix that. So by doing all this, by doing this chaos engineering and everything, we can improve the failure recovery strategies, right? So when it comes to the next part, that is chaos engineering, what happens is when what happens when an unexpected failure occurs. So chaos engineering, so chaos engineers is like part of the SRE. So they intentionally inject failures in the controlled environments to strengthen the system resilience. And next thing is release engineering, CI/CD optimization. So SRE engineers, we help the team to deploy faster without breaking things. Yes. So as I told you, we do keep on sending patches. We do keep on sending updates. So we must do it. We must deploy things faster. but without breaking things, without breaking the system, without breaking the application. And also we have to refine continuous integration and deployment, that is CI/CD pipelines for smooth rollout. So we have seen, in fact, we will see more into the CI/CD part later. But for now, I'm telling you that as a SRE engineer, you should deploy faster and you should refine your CI/CD pipelines as well. And then many people, again, I would say they confuse, because when I say about CI/CD, people might think, okay, is that my role is going to be a DevOps role? No. The thing is, many people confuse DevOps and SRE because they work together rather than replacing one another. But what happens is the DevOps engineers culture is focused on collaboration between development and operations. That's the reason we call them as DevOps, because they collaborate between, they do development and then they do operations. That is, they build, they deploy, they release, they monitor. But the SREs, they focus is, I mean, they're like engineering focused. Their approach is to check the reliability or make sure the reliability is available, right? And then the next thing is the DevOps engineers, they encourage automation. So they will like keep on adding automations to all their process, and then they do CI/CD, and on top of that they do fast deployments. Also, all these are things that we discussed so far in the SRE, right? But what happens with the SRE is, on top of all these actions, that is on top of encouraging the automation or on top of doing automation, CI/CD deployments, they do measure the reliability with SLIs, SLOs, and error budgets. So they measure all these part. And then the next thing is the DevOps practices apply broadly across software teams. But on the other hand, with the SRE, what we do is we apply the software engineering to operation challenges. And then the next thing is the DevOps engineers, they aim for agility and efficiency. That's the second thing, that because as a DevOps engineer, I want my application to be agile and also efficient. My process, my project should be agile and efficient. But the SREs, on the other hand, they think that their applications or their project should be resilient and stable rather than agile, and because agile and efficiency are speed factors, but resilience and stability are the other way. Like they ensure the reliability factors. So that's the difference between the DevOps engineers and the SRE engineers. So we're going to see more differences between these SREs, the traditional and DevOps. Yeah, but we'll go through them one by one. Okay. So any doubts until this slide? Shall we move to the next one?
So basically, like in terms of chaos engineering, okay. So who is responsible for this chaos engineering? Like what is exactly being done in the when we talk about chaos engineering?
Yeah. So as I mentioned, the SRE engineers has to inject the failures. So they have to intentionally they have to bring down the system, or they have to bring in, inject some failures to check what happens. It's something like performance searching. So what do? We increase the load and we check how the system performs, right? Same thing. The chaos engineers does the same, but in a different manner. They check the reliability of the application. They check the resilience of the application. So for that, they do injection. They inject failures. We're going to see chaos engineering in the upcoming sessions, but for now, just an introduction about that. Because as an SRE engineer, he has to do these. Like after an application has been deployed to the environment, the lower environments, he has to do a chaos engineering and check whether they are facing any issues, whether they are facing any issues that has been previously reported in the production environment. So that's the reason the SRE engineers has to do the chaos engineering, and chaos engineering is part of the SRE. Okay, shall we move to the next slide?
Yes.
Yes.
Yeah, thank you. So the next one, thanks, Mary. So the next one is getting started with SRE, where you're going to see where does this